Personal finance practice problem using OneNote. Investment to meet goal using a present value calculation. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side. We're in the Practice Problems tab, down in the 1161 Investment to Meet Goal Present Value tab. Also note, when using OneNote, look at the Immersive Reader tool. Our presentations will also be in the text area, same name, same number, but with transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, got the information up top, calculations on down below. We're looking at an investment scenario. There's typically two kind of investment scenarios that probably come to mind when you're thinking about investments and planning for the future. One is in a situation where you're saying, hey, look, I'm going to save as much as I can. I'm going to put that savings away when I can, and then I'm going to let it grow and see how much I will have at some future point. So then the question will be, I'm going to save as much as I can. Where will I be at some future point if I was to do that? The second method, or the second thing that will often come to mind, is you having a particular goal, first setting the goal, and then trying to see how much you would need to save in order to meet the goal. That's what we're going through here. That's similar to like a retirement plan where you're saying, I need this much money. How much would I have to put away to get there? Or if you're saving for a college at some point in the future, or a car, or something that you're going to be purchasing in the future. When you're looking at that type of problem, you're setting a goal and seeing how to get to that goal. There's two ways you can kind of do that with regards to our time value of money calculations. One is a calculation where you're going to be putting multiple payments in a set interval, in which case we can use an annuity type of calculation. The other being that you're going to think about how much you'd have to put away today in order for it to grow without you putting any more money in there, just simply from the interest to meet that future goal. So let's look at what we have here. How much would we have to invest to have in the future $2,400 with a rate of return of 6% in 5 years? So we're not talking about a situation where we're going to put multiple investments in this case. We're going to put one-time investment, just let it grow at what we assume or estimate will be 6% to get to the end result of the $2,400 from that growth after 5 years. Now, when you first think about this, you might first think, well, that sounds like something that I'm kind of projecting into the future. So your first guess as to the calculation you might use might be a future value calculation, although it's actually a present value calculation. And the way you can kind of see that is you could say, well, I see what my future goal is. It's the 2,400. What I need to do is present value it back to today, discounting it at the 6%, where then that's going to be my starting point. Whereas if I started at that point and then increased it on the future value at that 6%, I would get to the 2,400. However, again, a lot of times people don't quite see that and they say, I'm kind of planning to the future. Maybe it's a future value calculation. You can do it with the future value calculation, but if you use the Excel formula, you'd use like a goal seek, right? You'd be solving for a component in the equation. So let's first start with that and make the assumption that we said, maybe it's a future value type of thing, and let's put it into Excel and see how that might jog our mind. So the first thing you would do on any of these present value ones is, if you don't know what to do, start typing something into a function and see what the unknown is, and that can help to kind of jog your memory. So I'm going to say, okay, let's type in equals negative to flip the sign, future value. The rate is going to be the 6%, so I know that. That's going to be there, comma. The number of periods, that's going to be 5. That makes sense. And then comma. And then we've got the payment. The payment represents an annuity. This is not an annuity because I'm not making multiple payments. So I'm going to skip that with 2 commas. And then we've got the present value. Now that should kind of jog our memory to say, well, the present value isn't that 2,400 because that's the future value. So that means that, the end result then on the future value should jog your memory to say, that means that should be kind of the result. What I don't know is the present value. And once you see that, then you'll probably say, maybe I should use the present value formula, which you can do because obviously there is a PV formula, or you can continue on with this calculation using goal seek, solving for the present value. In other words, if you were to enter this in and use the cell of this cell and just enter some number, guess about what that number is, say 1,000 or something like that, and then get a result, you would then figure that the result needs to be 2,400, the future value, and you can then ask Excel to change this cell, the present value, to whatever it needs to be in order to get the end result to be that 2,400. And hopefully that can give you an idea of how these two formulas are kind of related. But also, then we can solve for the present value, and we can use the function for present value. So of course you can then say, okay, let's just do the same calculation with the present value. We're going to say negative present value. The rate is going to be that 6%, comma, number of periods is going to be 5, comma, the payment, there is no payment because it's not an annuity, but present value of 1, therefore 2 commas to get to the future value, which is going to be that 2,400 because that's my end goal. That means where we need to start then, the starting point would then be 1,793. Therefore, if I started now, period 0, at 1,793 about, there is rounding involved here, and it increased at a rate annual compounded of 6% for 5 years, I should get to the end result of the 2,400. Now, once we see that, it's a pretty straightforward type of problem. It's just a present value type of problem. We could do that with a table as well. Before I do the table, though, I'm going to scroll down to this type of running balance calculation, because this is the two types of calculations in practice that are most practical to you. We'll be using the Excel function typically, and then getting a better comprehension, verifying in your mind what has happened by then using a running balance calculation. The two things that you might then need for school is, of course, if you're taking this in a classroom setting, the algebraic equation and the tables, because they might take away your calculator and force you to do some funny things just to prove the concept, or make you feel stupid or something. No, in any case, so we're going to say, okay, we got the running balance table, which is going to be 0 through 5 here on the years, and we're going to then start with our starting point to kind of prove this to us. So we said that our starting point is 1,793. We're going to prove then, using our table, that if we were to compound 6% annually for 5 years, our ending result, where we will be in the future, is the goal that we wanted to get to of the 2,400. This will both prove that in our mind, and it'll also give us more information to see what the increase basically looks like as we see this, and you can then conceptualize better what would happen if you change something like the interest rate and so on. So if we were to say, okay, if I took this is a rounded, there's rounding involved here, but 1793 times the 0.06, that's going to give us the 107.58, 108 about, rounded. 1793 plus that 108 would then give us the new balance of the 1901 about. Taking that times the 0.06 means that then in period 2 we would be earning an increase of 114. Adding that then to the 1901 would give us our balance of the 2015. Taking that, multiplying that times 0.06 gives us our increase of the 121. Adding that then to the 2015, we get about the 2135 about. Taking that times the 6%, 0.06 would then give us the 128 about. Adding that to the 2136 gives us about the 2264, and one more time times the 0.06 would give us the 135 about. Adding that to the 2264 gives us then the 2,400 about, which is of course our end result, verifying that we did indeed do the right calculation, and we can see some what we got in terms of the increase, in terms of a year-by-year increase. All right, now let's do it with the mathematical equation. You could plug this in algebraically, which simply be a present value calculation equals the future value times or over, future value being the end result, 2,400 divided by 1 plus r, which is going to be the 6% to the end periods, which is going to be 5. We're going to plug this into a table type of format, which is good practice for your Excel skills and just visualizing tables, putting it into a format similar to a tax return or financial statement. So we then have the future value, the 2,400 in the outer column. We're going to pull into the inner column the 1 plus r to the n periods, putting a colon indicating that this will be a subtotal, also indicated by it being in the inner column. 1 plus r, that's going to be this bottom half of the equation, r 6%. Adding those together, we get the 106%. Checking that in the calculator, we get the 1 plus the 0.06, 1.06 or 106%. Taking that to the n periods, 5 years, needing a financial calculator to do so or some other calculator. I'm going to take a scientific calculator. So we're going to get scientific on it. We're going to go scientific calculator. Make sure you got the calculator you need and that is legal if you're basically taking a test in a school setting. You want to have it do all of the things it needs to do without violating any things that it's not supposed to be able to do by the school. Anyways. And then we're then going to say that's to the xy with the caret. Did I square it? To the xy, and then it's going to be to the 5, and that'll give us the 1.33822. Let's bring it back to the normal calculator. So that's going to be the 1.33822 about. And then we can do the division problem, which is going to be the 2400 outer column now, divided by about 1.3382226. That's going to give us about the 1793. There we have it. Now note that if we want to get the amount from the table to see how the tables work, you can then take this number and divide it by the 2,400, and that'll give you about what the table is. This is rounding kind of messed up here, but 0.747258 about is what should be on the table. Remember that the tables are actually taken to only 4 digits, so that means that the real number is closer to this, and therefore the tables will be rounded. So if we go on to the tables then, down below, it's a straightforward table type problem. The investment's the 2,400. We're going to look up on the table, making sure that we have the right table, which is going to be a present value table, not an annuity table in this case. And we're going to look for the 5 periods and 6%. 6% and 5, 6 and 5, 6 and 5. Here's the 6, there's the 5, 0.7473. So there's the 0.7473. Multiplying that times the 2,400, 2,400 times the 0.7473 gives us then the 1794. Once again, note that that amount from the table rounded to 4 digits means that you will result in a rounding difference typically from the table calculation to the calculation using formulas or Excel references. Usually not something that's going to be a problem for decision making due to it being immaterial, but something that if in a school setting, which is probably the only setting you'd be using the actual tables for, you want to be mindful of, because they can use that to kind of force you to use one method or another.